Okay, great. And with that, it is my pleasure to introduce our presenter for today's webinar, Dr. Rebecca Schmidt. Dr. Schmidt is a tenured full professor and molecular epidemiologist with over 20 years of research experience in epidemiology, gene-environment interactions, epigenetics, maternal and child health, and a primary emphasis on neurodevelopment and autism. Her pioneering research focuses on how prenatal, environmental, and nutritional exposures interact with genomics, molecular mechanisms, and developmental programming to influence the neurodevelopmental outcomes of children. She further investigates epigenetic, transcriptomic, and metabolomic markers of autism to increase understanding of biological pathways potentially involved. She leads a large biorepository and several child development cohort studies, including the Marbles Autism Pregnancy Cohort, the Be Safe Wildfire Pregnancy Cohort, and the Peach Cohort site for the National ECHO program. Thank you so very much for being here, Dr. Schmidt, and I will pass it over to you.
Thank you for having me. And I'll go ahead and get my slides sharing. Everyone can see my slides. Should go presentation mode. Yeah.
There we go. Yes.
Oh, okay. It's a little delayed. Okay, so I'm going to be talking about specifically prenatal wildfire smoke exposure in relation to child development today. But I wanted to start by kind of how this came about. So in general, my research program, as kind of was alluded to in my introduction, we study all different kinds of exposures, primarily during the prenatal period, and how those can influence later child development. And also looking at kind of the mechanisms and biologic pathways involved. And today, again, I'll focus on wildfire smoke, but just kind of wanted to throw out there that this is one of many different types of exposures that we look at, and that includes not just what's typically thought of as environment, but basically anything non-genetic, which could include things like stress and other factors. And so we've been doing a lot of work in the context of the Marbles cohort study, which was mentioned. And so this is a study where the families already have a child with autism and then are planning to get pregnant again or are pregnant again with a new pregnancy. And then we follow that pregnancy through until that child is around age 3. And now we have funding to keep following them even into their teen years. And those children, those younger siblings of this older child with autism, also are more likely to get a diagnosis of autism or other neurodevelopmental conditions. And so in the context of this study, we've been looking at a lot of biologic markers that might predict later outcomes, but also a lot of different exposures during the prenatal period and how those might influence neurodevelopment. And in this study, we were enrolling and we're very close to our moms. And at that time, there were the 2017 Napa Sonoma, the Tubbs fire broke out in California. And a lot of our moms were exposed to smoke during that time and at levels that they hadn't previously been exposed to. And many of them were pregnant at the time and had concerns about what that smoke exposure how that might impact their developing baby. And at the time, we were kind of looking into research on the topic, but there was very little out there. And this was kind of the start of where we started experiencing these longer, more severe wildfire seasons with more smoke days than ever before. And this is all within the last, decade, really within the last 5 or so years. We've had several of the largest and most destructive fires, including hitting urban areas, which is fairly new. And that's, a lot of reasons for that. One is that we're building urban areas into areas that are prone to wildfires, but also that there's just more wildfire exposure, and it's just more likely that they're going to hit these areas. And this urban wildfire smoke is even more of a concern than traditional vegetation fires where it's burning grass and trees, because now you're combusting organic material as well as like building construction materials, things like melting cars and refrigerators and all kinds of things that include plastics and other things that could release different chemicals into the air than when you just have vegetation burning. And so there have been studies just looking at toxicity of these wildfires in general, and show more toxicity than ambient air pollution that we're used to, but also including these urban wildfires where there's even greater toxicity shown. And we now see millions of pregnant women in the United States are breathing air contaminated with wildfire particulate matter. And that's becoming even an increasing concern in more recent years, where we're having even East Coast people getting the Canadian wildfire smoke, for example. And now it's nationwide, everyone's experiencing more wildfire smoke. And so we had been conducting this study in our cohort, our Marbles cohort, and these moms asked us whether they should be concerned about these wildfire smoke exposures. And we didn't really find a lot of literature because this was a fairly new phenomenon for these wildfires to be as big as they were and affecting as many populations at concentrations of particulate matter that were higher than before. And so we decided that, given what we did know on air pollution already, so this is generally studies of air pollution from traffic and industry and other sources of pollution. But we do know that, those early developmental period around conception all the way through the first years of postnatal life are periods where that baby is experiencing rapid growth and development, and it's particularly susceptible to a lot of different environmental exposures, including air pollution. And there are already their organs are being developed. Some are particularly sensitive. That includes the brain, which develops all through that period into postnatal life. And we already knew that prenatal ambient air pollution, so again, air pollution from other sources like traffic, was linked to adverse birth outcomes. So that includes things like low birth weight, preterm birth, and then also later child neurodevelopmental outcomes, including things like autism and attention deficit hyperactivity disorder, or ADHD. But this was all based on studies of ambient air pollution, not including wildfire smoke in particular. And as mentioned, wildfire smoke is a bit different, especially these newer exposures to wildland urban wildfire smoke hitting urban areas. And so we decided we should probably study this and find out some answers for our mothers to see if we could learn more about how concerned they really should be during these wildfire events. We did have some information coming out that early on that smoke exposure did lead to black carbon being deposited on the fetal side of the placenta. So we did know that fetus who's developing is exposed to at least the carbon that's coming from wildfire smoke. And then also, we knew that components of smoke, including particulate matter, PAHs, these things were shown to trigger inflammatory damage, and even in ways that could impact placental development and function, which then ultimately could impact fetal growth. And that was kind of the thinking behind a lot of the air pollution studies early on how they are impacting birth outcomes. And then prenatal wildfire exposure was then linked in several studies to these same birth outcomes, including low birth weight and high birth weight, also preterm birth and other birth defects like gastroschisis. And so we did see some of this overlap between how ambient air pollution was affecting that developing fetus, and wildfires were also showing similar impacts on growth and development. with prenatal exposures. But there were a lot of questions that remained on, what's the key exposure time? Like, are there certain parts of periods during pregnancy or postnatal life that might be the most important? And then also, who is most vulnerable? Also, the mechanisms involved. And we really don't understand whether we don't even understand exactly how it works with ambient air pollution, but things like inflammation are thought to be involved. But we didn't know if that would be similar or different for these kind of different wildfire exposure. And then also, there really wasn't much out there on long-term child outcomes in relation to wildfire smoke. And the reason we kind of think it might be important to look at these long-term outcomes, even though you have this, very early period of life with this acute exposure, but we know that exposures during that period of time can lead to long-term effects. And this is thought to be mostly due to this epigenetic programming that can happen early in pregnancy. And so what that means is there's a period of time where that developing fetus undergoes, it has these methylation marks, which are these little carbon groups put on the DNA that influence how it's expressed. And there's a period where all these marks, except in certain places, are wiped out and then reestablished. And the reason for this is thought to prepare that developing fetus for their environment. And so that goes on really early, like right after conception in the first couple weeks, and where it's wiped out and then slowly reestablished throughout the rest of pregnancy. And so we can look at kind of this timing as maybe a key point for leading to differences that could persist throughout life. So it's often called the developmental origins of health and disease, or DOHAD, because we know that some of these events or exposures during this period can have these long-term effects. And then we can also look at epigenetic markers to kind of understand those biologic changes that were associated with exposures, especially during that window, and then also with later outcomes. And part of what I find interesting is that there's these changes that happen in the fetus, but also in the placenta. The same process of having the methylome wiped out and reestablished is going on in the placenta. And so there's kind of these leftover marks that the placenta can show you that mark early prenatal events. And I'll come back to that a little bit later. But so at the same time that these moms were being exposed to these wildfire plumes, we have at UC Davis a non-human primate center where we have rhesus macaques who are living outdoors and breathing this smoke. And this time, in the more recent fires, especially the 2018 Camp Fire, they hit a period where the female rhesus macaques were pregnant. Usually they only have certain times where they mate and are pregnant, and previous wildfires had missed those windows, and then the babies would have been born already and it would have been postnatal exposure. And those postnatal exposures were also associated with different health outcomes later in life for those babies, including mostly respiratory and immune dysfunction. And they were long lasting, so they persisted all through adulthood, even after one exposure postnatally. But these more recent, the Camp Fire had this early near conception window, and we did see that led to longer term behavioral differences in those baby macaques. And that included things like behavioral differences and also memory impairment. And so we also were able to look at some of the biologic pathways that were changed due to those exposures. Again, the postnatal exposure was associated with methylation changes or epigenetic changes in the nervous and immune system genes, while the more recent prenatal ones we're still looking into. So we began our own study of humans during that time, and we recruited moms that had been either pregnant during the wildfires or right after the wildfires, all in Northern California. And we asked these moms, well, first we enrolled them throughout various fires. So we started during the 2017 Napa Sonoma wildfire, or the Tubbs fire. That was followed by the even larger, more devastating Camp Fire in 2018. And then there was a smaller Kincaid fire in 2019. We got some moms for that. And then the 2020 complex fires, which then became the largest, most severe fires ever. And then that was followed by a 2021 Dixie Caldor fires, which then became the largest and most devastating fire. So we just kind of had a roll of intense wildfires in Northern California during those years, and we enrolled moms all throughout with the limited funding we had. And we collected biospecimens and survey information from these moms throughout for each of these fires. And our hope was to determine what their exposure loads were, but also their mechanistic responses and health biomarkers. And so just to mention a few things that we collected. We got information on their wildfire experience, including if they evacuated, where they went, whether they used masks, things like that. And we also had them complete a perceived stress survey, and we had demographic information, and then also some information on the mom and their pregnancy, and then the delivery and the baby's postnatal health. And we also collected biospecimens, as I mentioned. Here's a list of what some of them were. We didn't get all of them on everybody, but especially during the 2020 period, we, because of COVID, we had limited blood collection. So we moved to other things. But we did get, for most of them, saliva from the baby and maternal blood on many of them. And then here's just to let you know that the characteristics of these participants, most of them were non-Hispanic, white, and college educated, married, and non-smokers. And we tried really hard. We had all of our information in English and Spanish. We recruited as much as we could to get a more diverse participant population. But this is who ended up signing up, and it is sort of in line with the populations affected in those counties. And so you'll see that in a minute. So here's the areas where the fires were each year in a different color on the left. And then on the right, you see our catchment area for our study. And most of them are here in this darker blue within 2 hours drive of Davis and Sacramento, which is where UC Davis is here. And that was, for logistical reasons, because we wanted to keep in touch with these families. And we also now are bringing them back to have their children seen at the clinic, which is here in Sacramento. So we wanted to keep the distance short for those that we were going to see in person. But we also did have an online survey and offered mail-in samples for people in the broader Northern California region. The other thing to point out, so here's a map of where their home locations were for all the participants at the start of the wildfires. You can see kind of that they do congregate in that darker blue area around within a couple hours drive of Sacramento Valley. And then you can also see how it varies by year, kind of depending on where the fire was. And then we have these are the places they evacuated to. And the main takeaway here is that there's 6 not shown in this map, but for the most part, many of the moms who did relocate during or after the fires stayed within Northern California. They didn't go too far, and a lot of them still had exposure to smoke in that period. So we worked together with Sean Rafuse and others on some that NASA was doing these very complicated air pollution modeling, data fusion approach to modeling, where they take information from ground monitors that are throughout California, along with satellite information, and they model with the sensor network, which is kind of a newer addition. That's things like the purple layer sensors that you can have in your home. And then they use machine learning approaches to come up with estimates of daily mean particulate matter, specifically smaller fine particulate matter, or PM 2.5, during these wildfire periods for each year. And then we were able to link that. So here's what they look like just by each wildfire year that we collected over this time. So you can see in 2017, which at that time was a really big wildfire smoke event, but you can see the scale of it is much smaller in comparison to the 2018 wildfires that then broke out. And even the 2020 and 2021, those were much bigger, longer periods. You can see that those cover more months. It's a little clearer here. So this is what the actual wildfire smoke looked like during each of these fires, and the one on top is what our participants experienced. And so because these larger 2020 and 2021 fires lasted several months, you can see that for our participants, but you can also see that the scale isn't quite as high as like the 2018, because in 2020 the participants tended to be a little further away from the fires, so they didn't quite have as much exposure as they could have, which maybe is a good thing. And so early on, we looked at some of the acute health factors. We looked at their surveys on their reported symptoms. This was, we asked many months after the fires, some up to a year later. I guess I thought was surprising, the biggest, most commonly reported symptom, I guess, of the wildfire experience was stress and anxiety. And I guess it's not too surprising, because a lot of these families had to relocate, or even just worrying about all the smoke exposure, or whether the fire was going to hit their homes, and those kinds of things. About 50%, so about half of the moms had reported any symptoms, but that included other symptoms that you might expect, like the respiratory symptoms, like irritated eyes, sore throat, and cough. All of those were very commonly reported in about a third, but that was only in right during the month of the wildfire, and maybe the month or two after. But then it really goes down, and the percent reporting those respiratory symptoms really went down, and they weren't long-term in general. There were also other more mental health symptoms reported, like trouble sleeping and depressed mood. And those also kind of started out a little bit higher, up to maybe almost 20%, but then persisted around the 5 to 10% for a little while after. And then we looked at whether moms that had higher particulate matter exposure, whether they had more symptoms. And we did find, especially for the respiratory symptoms, as might be expected, that when they had higher exposure to the particulate matter, they also had reported more often things like cough, sore throat, a cold, and even wheezing in the chest, so symptoms of asthmatic, but not necessarily asthma attacks. And then we did also find some of those other physical changes, like moms that had higher concentrations of smoke were also reporting more headaches and nausea, as well as rashes. And then also some of the mental health symptoms, like depressed mood and agitation, were reported more often when they had higher exposure. We also looked at some blood markers of many different chemicals, so 55 different chemicals. And we looked at things that we thought would persist in the blood because these blood samples weren't collected until months after the wildfires. And the good news is we did not find higher levels of most of these chemicals. So things like PAHs and flame retardants and things that we thought moms might be exposed to and might persist. But we did see evidence for long-term inflammation for those who had higher exposures. And then we did, a couple years later, when the kids were a bit older, so around 4 or 5 years old, we went back and asked moms to complete surveys as part of a pilot. So we only had funding to do about 100. So that's what we enrolled, about 52 males and 54 female kids. We had the moms complete the child behavior checklist for their kids. And we also linked that to ground level PM 2.5 at their addresses. And then also use regression models to look at whether those that had higher exposure to particulate matter or smoke, whether their kids had more of these behavioral problems on the child behavior checklist. And we're actually kind of surprised to see that across the board, moms who had higher exposure during the prenatal period to smoke, also their children tended to have more of these reported problems. So that includes things like internalizing and externalizing. So internalizing are more things like depression and anxiety. Externalizing are more of these oppositional defiant problems or more outward ADHD type of problems. And you could see that across the board, the kids that had higher exposure to smoke in utero during pregnancy also reported more of these symptoms of 4 to 5 years later. But you can also see when we separated out the males and the females, and again, our numbers are a bit small when we do that, but it was really driven by the male kids. And there could be reasons for this. One being that a lot of males tend to show these symptoms a bit earlier than females. And so it could just be driven by their age. So now we're following these kids up across the entire cohort. And this was really only covering kids that were exposed to the 2017 fire, which, if you remember, was fairly small in comparison to the 2018 wildfire. So we had some 2018 wildfire exposed kids, and they were really driving these effects. So we think it's really this kind of a threshold where if the kid is exposed to these really high particulate matter levels in pregnancy, they were more likely to have some of these symptoms later. So we also got a study to look at all of California on a much larger scale, and this was an EPA grant. And so now we were looking at over 11 million births in California across 2 decades. So going from 2000 all the way through 2021. And we wanted to look at whether, again, these wildfire exposures during pregnancy, how they related to pregnancy outcomes, including preterm birth and birth weight, and then also other child neurodevelopmental outcomes, including autism. And so, again, we worked with collaborators, this time Mike Kleeman, to use fancy air modeling with these chemical transport models, and assigned air pollution to the entire state of California across every year, every hour of every day of every year. And then you can see here over the 20-year period that Northern California really had higher overall wildfire pollution. And then the unique thing about Mike Kleeman's model is he also had a specific source of the pollution. And so we were able to separate out regular biomass burning. So that's more vegetation fire, from wildland-urban interface. So that's more of those wildfires that hit urban areas and melt, buildings and cars and all of the other things. And so just to kind of highlight that, again, this is just California, but across the last 2 decades, most pregnant women were exposed to wildfires, at least one wildfire episode during pregnancy. So about 6 million of 10 million births had been exposed. But that's at a low level. And then it also varied by year. You can see how it changes over time. There's good wildfire years and bad wildfire years. And then on average, there are about 300,000 exposed every year. You can see that it looks a little different when we focus on these wildland-urban interface wildfires, so the WUI fires that hit urban areas. And you can see that that's been increasing. So you'll note that total wildfire exposure hasn't really steadily increased over time, but the number hitting these urban areas has increased over time, especially in the more recent years. And the other thing to note here is that we have the color code by socioeconomic status. And you can see that there's a lot of overlap, not a big difference across the different classes. And this is important because a lot of the air pollution work is it's problematic because the people who are exposed to the most air pollution tend to be lower SES. And that's not the case with wildfire smoke, which tends to hit, if anybody, some of the highest socioeconomic status people have the highest exposure. And that's, again, because these big houses are built into kind of forested areas, and they tend to be hit by wildfires more often. And so here's just in contrast, this is what ambient air pollution looks like across the same 2 decades. And you can see this very clear gradient on the lowest SES in blue here is always at the highest mean air pollution level. And then the highest in purple, socioeconomic status is always at the lowest. So a pretty big contrast on who is being exposed. So why did we want to study autism? I think most people know what autism is, but just to make sure we're all on the same page, autism is a neurodevelopmental disorder. So it's characterized by persistent deficits in social communication and social interaction, and also the presence of restricted and repetitive patterns of behavior and interests or activities. And we know that it has a neurobiologic basis. We know this because there are signs of aberrant brain development that can be seen in imaging and also in autopsy studies. And usually the symptoms are present by the time the child is age 3 years old. But the diagnosis is very complex. So not everyone has always been, all cases are not always met. And some go until they're older. If they're a less severe case, it takes longer for them to get diagnosed. And generally it takes specialists to make the diagnosis. The other thing you might note is that autism prevalence has been increasing over time. Prevalence now affects 1 in every 31 children in the United States by the time they're age 8. And it also affects boys more often than girls. So we did this statewide linkage study as part of that EPA grant, where we're looking at, again, daily particulate matter across the entire state, across all those years. And then we are linking that to what they're exposed to across pregnancy, and then looking at birth outcomes and autism. So I'm going to just focus on the autism findings for today. And so that was including the years 2001 through 2019. We did include the last couple years because we wanted to give those kids that are exposed in utero time to age into a diagnosis. And then we linked these their air pollution during using their birth addresses to later outcomes of autism on the California Department of Developmental Services, and they capture about 80% of most autism cases in California. Because California offers services for children who are diagnosed with autism, most people who are diagnosed do get into the system, and so it's captured with this data. We did analysis looking at their exposure, and we found that biomass burning itself wasn't really associated with higher risk for autism. But again, exposure in that wildland-urban interface, or the WUI wildfire, was associated with increased risk for autism in that child later on. And especially, the higher levels, the very highest percentiles were associated with the highest risk. The other thing we looked at was episodes. So again, the number of wildfire episodes they were exposed to during pregnancy. And then we also looked postnatally. And we didn't see anything for postnatal wildfire exposure, but we did see this increased risk for autism associated with pregnancy exposure to more wildfire episodes above 35 micrograms per meter cubed, which is a fairly high intense wildfire event. So we also looked at 9 micrograms per meter cubed. I didn't show it here, but we did not find associated risk for autism with that level. And then one of the interesting findings for this study, we saw a previous study on preterm birth in California where background air pollution made a difference on their risk associated with preterm birth. And so we stratified by their background levels of air pollution at the start of the wildfire event. And what we found was that if people were in the lowest 2 quartiles, or like they had lower background air pollution to begin with, then their risk associated with wildfire exposure was higher for autism. And so this was kind of a unique finding that we have a lot of ideas about, but it's basically the ones that are experiencing higher levels of air pollution all the time might not react as much to new air pollution from wildfires, is our guess. But it is important just to understand that those who have lower exposure to begin with might have be more susceptible to the impact of these wildfires at least on autism for the child. And so again, this is just summing up that study. I just want to jump. So if you want to see actual risk ratios and confidence intervals, they're here. But the bottom line is that I wanted to point out that, again, the associations with autism were most pronounced among children in the lowest quartile of background air pollution, and also when they had the highest intensity wildfires. And so that there's like a threshold where if it gets above this level of over 35 micrograms per meter cubed, that seems to be more important. And then if it's lower levels, it doesn't seem to make as much or any difference on risk. And so this highlights the potential for long-lasting neurodevelopmental disturbances associated with extreme and recurrent wildfire smoke in pregnancy. And so this was recently published this year. And right before we published, this other study came out in California, again, looking at Kaiser data, and they also looked at wildfire exposure and autism, and basically found the similar thing where they didn't find any association with mean wildfire particulate matter. But when it was more than 10 days of wildfire exposure, so basically more exposure, then they had were associated with higher risk for autism later. And so completely, separate study and showing similar results. So I think there's reason now to be concerned about these longer term. So we're now looking at this, and there's the National ECHO Environmental Influences on Child Health Outcomes program, which is the largest United States cohort of children starting in pregnancy that's ever been done in the United States, which I'm pretty excited to be part of. And their goal is to enhance the health of children for generations to come. And they're planning to have, and I think they already have, over 50,000 children in this study. And they're looking at all different health outcomes. So like these perinatal outcomes, like birth weight and some of those factors, but also respiratory impacts, and then also obesity, neurodevelopment, and then positive health or well-being. And so they're looking at all different outcomes in these children. And as part of team science with a bunch of other collaborators, we're going to be looking at prenatal wildfire particulate matter exposure in relation to neurodevelopmental outcomes in this nationwide cohort. And then we also can look, because this cohort study collects biologic specimens and lots of survey data, but it's also a much larger study than like what we have for BSAFE. We plan to also use some of these specimens to look at some of the biologic pathways that might be involved. And then just to note, as I mentioned, it's a nationwide problem. It's really a worldwide problem for smoke exposure. And as it highlighted in this publication that came out last year, about over 99% of pregnancies had exposure to at least one smoke day. But that was, over concentration of 0. So basically, there's fewer that are associated, that have exposure to higher levels that might be of more concern. But there's definitely enough exposure across the nation to be able to study this and learn what levels are really where the concern starts to build up. And then we also are going to be collecting in real time, when there are smoke events, use of masks and air cleaners and other smoke mitigation behaviors, and track addresses for those who move, which was a limitation of the large California studies. And so again, I kind of go back to here where I talked about some of the mechanisms. And I think to me, it's interesting that we can use the placenta as kind of a time capsule of some of these exposures that happen during gestation, to understand the biologic pathways that might be changing in relation to these exposures. And so I realize this is a very complicated looking slide, but the point is that we can look at these methylation marks all across placenta tissues. And so we have over 230, and this is again bringing back into our original marbles autism cohort, where we have placentas collected on most of those families, on those births. And then in addition to some of the BSAFE families, where we also were able to get to their delivery and collect those specimens, and which wasn't always possible, especially during COVID, and we were able to look at some of these marks across those placentas. And the main takeaway here is that we did see changes in marks within inflammatory response pathways and synaptic or neurologic pathways. And so that was kind of interesting and something we're following up now. Again, this is just kind of showing with wildfire exposure, which pathways were most changed in terms of methylation, and kind of looking at it a different way. but the differentially methylated regions, or the DMRs, for males and females separated out. But in both lists, you do see these axon guidance pathways and things that relate to neurodevelopment. And so that is something we're kind of looking into now to understand more. I'm going to skip through this. We also look at marks that are associated with autism. And I'll just say quickly that one of our top markers that's associated with autism in the placenta also is changed in terms of methylation with wildfire smoke exposure, and also with prenatal vitamin supplements in the opposite direction. And so the reason I bring that up is because there's previous epidemiologic studies done by us and others showing that, there are certain exposures that might be able to counter the air pollution exposures. And so this just kind of shows with pesticides, but also with air pollution, that if you have the exposure to air pollution, but also the mom takes folic acid supplements really early around conception, that tends to lower the risk associated with autism. And it kind of sounds out there, but they tend to both influence similar pathways. And there's experimental studies in animal models that show the same thing, but also even in human adult models, but not pregnant women, where they exposed people to air pollution specifically, looked at the epigenetic changes that it made, which it did, and then if they gave them supplemental folic acid during their or after their air pollution exposure, it reversed those methylation changes. And so that's just kind of proof of concept that maybe there's ways to counter some of these air pollution effects if we understand how it's working a bit better. And so now what we're doing is, again, in that Be Safe cohort of moms that were exposed to pregnant fires during their pregnancy and their children, we're now going back to all these families now that they're older, around 5 to 9 years old, and we're going to be assessing them for other child health outcomes, including respiratory outcomes, because that's something the moms were concerned about, and because the non-human primate studies and other air pollution studies do indicate there could be increased risk for things like asthma after exposure. But we're also going to be looking at the mother's health and how she's doing years after the fire, as well as doing some of these markers, looking at markers in some of the biologic specimens that we collected earlier. So one of the things that moms were really concerned about was metals exposure, like heavy metals. And they have good reason to be concerned because in the recent LA fires, there were certain metals, including hexavalent chromium-6, the one that's in the Aaron Brockovich movies that is a carcinogen, but also could be a teratogen or influence development. And so we are looking and using some of the specimens we collected, like hair, and now we're going to be doing child and mom toenails and fingernails, which kind of the metals collect in there, so we can see that were collected back at the time of the fire, and look and see if there are any certain metals that are higher for those who are more exposed. And then we're also going to look at some of these epigenetic markers, again, in the child's saliva samples, as well as try to look at see if we see some of the overlap with what was shown in the non-human primate studies, but also looking at pathways that might be influenced. And then we also have other studies going on to kind of try to understand how these associations might be working. But the thing we're really trying to build up to is to do intervention studies where we're kind of learning about what times are most important and what exposures are most important, and then look at how we can intervene. So intervention studies are on the horizon, so we can do randomized trials to things like air purifiers and see if that makes a difference in children's health down the line. So with that, I will also do a call out to, I think we know enough to know that breathing in wildfire smoke while pregnant is not good for you or your baby. And so here's a list of 10 ways to protect your health and your baby's health when the air is smoky. And this is just pulled from a University of California site, but there are other sites, and all these links are will take you to the sites that give advice on what to do when there is smoke in the air. But one of the things so I'll go through some of these because I do think it's important to note that you should get used to looking at air quality index if you're going to be spending time outdoors, especially while pregnant. But all the time. And so check the air quality. You can get apps like the Air Now app or things like Purple Air, and look at whether the air is clean that day you're going to be out there, and then use caution. So for example, if it's an orange day, then you might not want to do vigorous exercise outdoors. You might want to instead go do it indoors where you have the doors and windows closed and run the air conditioning to recirculate the air with a filter that cleans out some of those particles and keep your air cleaner. Also, the other thing is if you're going to have to be outside, wear an N95 mask. So they're shown here. And it needs to be tightly fit on your face. So it's really hard to do this for children because they don't tend to make them small enough for them to get a good seal. But for moms that are pregnant, it's advised to, if you're going to be spending any time outdoors, when the air quality is not good, then you should be wearing an N95 mask to help clean out some of those, keep those particles from getting in. Because it's not just the particles. So the particles go in, they cause inflammation, but there's also things like maybe heavy metals or other chemicals riding along those particles. And so you don't want to breathe those in. And also, like air purifiers are a good idea to have in your home. Make sure you change the filter, so when you go to buy them, look at how much the replacement filters are and make sure that you remind yourself to change it every year at the same time or something. But also, if those are kind of expensive, you can build your own. So we have this the Corsi Rosenthal box, basically using a box fan and air filters. You can make these inexpensively and they work. They're shown to be validated to be effective on cleaning air. And so if you have larger spaces and you can't afford a air purifier, those work well. So those are just some ways to protect yourself from smoke, but also protecting your baby at the same time. And then I just want to mention, this is a huge effort with lots of collaborating investigators, including some junior investigators whose work I showed, which include Carl Osharkey from UCLA and Amanda Goodrich here at UC Davis, and lots of our funding sources. And again, probably the most important thing is a thank you to all of our participants for being willing to provide information and samples to help us understand these exposures better. And we will use that to go back into these communities and educate them on how to protect themselves down the line. So, and thank you for your attention. And I'm open to any questions.
Thank you so much, Dr. Schmidt. This is Claudia here, and I do have a few questions, but I see Lori came off of mute. So, Lori, if you, please go ahead.
Okay, either way. There is one question in the Q&A, and I'll start with that one. Do animal models also show neurotoxicity from air pollutants? how strong is the evidence from epidemiological studies?
Yeah, so kind of two different questions. So the animal models, it's tricky. I mean, they do show toxicity and more toxicity with wildland urban interface type of smoke. But it animal models don't always transfer to humans, right? And so that's why we in particular focus on the non-human primate because they're a little closer to us. But even then, we see differences across species. And so, but generally they do show similar effects in terms of inflammation and even epigenetics, which we weren't sure we would find. We are seeing some overlap. And then as mentioned, some of the behavioral outcomes in the offspring do seem to show similar differences. And so I do think in this case, they might be a good, it doesn't take them as long to develop these things, and we can do controlled studies. And so that is work that's ongoing, and they don't always translate, but generally they are showing similar things in terms of toxicity and health impacts of wildfire smoke. And then in terms of the epidemiologic evidence, I mean, what I showed you today was basically, at least in terms of autism or neurodevelopmental outcomes, that's all that's out there so far. But there are a lot of studies ongoing. And so I think right now they seem to show very similar findings. And so that's usually a sign that, maybe there's something really there. But like I said, in that larger national study, they have also looked at birth outcomes and shown very similar findings as the California studies on birth outcomes. And so we are seeing similar things in terms of those outcomes. We expect to see similar things with neurodevelopmental outcomes, but it's just starting. And so I think, it takes a lot longer to get those studies done, just because you have to wait until the child's old enough to be able to look at some of these outcomes. But so far, from what we've seen, I mean, these are really large studies, and the fact that they replicated in a few different populations is maybe a sign that it's decent enough evidence that I would take precautions.
Great, thank you for that. And then we have a comment. Thank you for this informative presentation. I've seen several comments. The next question is, do prescribed burns have the same effects, or is this based on longer burning fires?
Great question. So we actually are able to look at both. And so we plan to do a bit more careful job of separating those because it's a very important question because, the prescribed burn might prevent some of these larger wildfire exposures. But then you're getting exposure and you're creating it. What we've seen so far is seems to be a threshold where if you're above that level and it's persistent a little bit over time, but really high concentrations of particulate matter are more concerning. And there aren't really any concerns at the lower levels that it seems like prescribed burns wouldn't reach those levels. And they might prevent us from getting to those really high wildfire levels. And so right now it seems like prescribed burns might be a good idea. Of course, if there's one happening near you, and you might want to wear a mask and not get that exposure either if you have the choice. But it does seem like that might be an effective way of reducing total risk.
Mm-hmm. Great, thank you.
And again, those are also just vegetation, so not as concerning as things like, when cars are melting and buildings are burning. So another factor that the smoke itself is probably a little less toxic.
Right. I wonder if children exposed both prenatally and raised where wood heat and wood smoke could have some of the same outcomes.
Yeah, so interestingly, so the measure we have for biomass burning includes wild wood fire smoke from like when people have a fire in their home and goes out the chimney. And so we actually track that as well. We, again, like those, it's interesting because those levels were really high early or 2 decades ago, and then those have decreased. People have used them less and less, while the other exposures have increased. But we have not found, again, at those lower levels, but in the home, it's probably still a good idea to use like an air purifier if you're going to be burning at the fireplace. But it's probably better, not to expose yourself to more any kind of smoke if you can help it. I know I'm concerned about it because we have a wood pellet stove from our home, and I stopped using it. I found these.
Right. Once you started doing this research, you said no more.
Yeah.
Right. So there is a comment. So N95s will filter particulates, but not the toxins themselves, reducing lung damage of those particulates. But this sounds far scarier regarding the exposure to the other chemical toxins.
Yeah. I mean, I think, again, it depends on, certain ones. So there's a lot of exposure science, I guess, on which chemicals, how far they travel during a fire. And that's all still ongoing. We're learning so much more, and each fire is pretty unique. And so it's really hard to get a handle on what each person over time, what they're exposed to. But there's a lot more going into that now, especially with the LA fires. But it is true that like we kind of have these models of the chemicals and how far they go, but we don't really know what each person is getting, I guess, in terms of their exposure. It also depends on, how much time they spend indoors and outdoors and all of those things that are a little hard to get at in terms of research. But the particulate matter tends to be kind of a good surrogate for exposure because, yes, those particles can be stopped by mass, but a lot of times, like I said, there's chemicals that ride on those particles, and so those are stopped as well. And so it still kind of gives you an idea of their exposure on how far those particulate matter travel, especially the fine and ultrafine. We actually looked at ultrafine too, which is even smaller particles that get deeper into the lungs and cause more damage. And so it's kind of the smaller ones that get through are potentially as or more concerning. So yeah, if we had a way to not be exposed at all, that would be the best thing. But at least the N95 mask will kind of give you some protection from some of the particles.
Right. And then one more question that I see asking for clarification. So when we have the hazy days during larger fires from far away, should pregnant women have precautions?
Yes. And I think, again, like you can check your air quality because sometimes it's hard. Sometimes what you see doesn't necessarily track with what you're breathing. For example, there were days I know during, I think, the 2018 campfire that here in Davis, we had orange skies and it looked scary. And I went to the pool, but I checked my air quality, and at the ground level where you're actually breathing the air was green, like it was clean. And it's because the particulate matter was kind of hanging out above where we were. And so sometimes that happens, but also the reverse, right? Sometimes you think it looks okay, and then you look at the air quality and it's not actually very good. And so it's really hard to eyeball it. I mean, if you do smell smoke, it's usually an indicator that there might be, reason to check at least. But it's kind of a good idea to check that air quality all the time. I know I've gotten in the habit in the winter, especially because you can have pretty bad air quality, again, from people burning wood fires and things. And there's these inversion layers that can cause it to just hang out where we're breathing it and keep it low to the ground. And that can be just as concerning. Those aren't getting as high concentrations, as some of these wildfire events. So just to kind of put it into relative, if they're on those days, anything above 20 might be kind of considered like kind of air pollution day, but these wildfires are in the hundreds. And so it's a pretty different scale, but still probably not good for you to breathe. So I would get in the habit of kind of checking it often. And a lot of times, we're trying to get media and other people to do a good job about like, oh, today's a, no burn day or an air quality concern day. Like they're trying to get that message out when it does raise up to those kind of orange levels that are concerned for more people.
Great. Thank you. And then just two more comments that I see. One, thank you. This is fantastic information, especially in our central Washington wildfire area. Looking forward to hearing more and sharing the information. And then a comment that the airnow.gov is an excellent site to add to your phone for instant access.
Yes. Yeah. That's the one I have on my phone.
Okay,
and
great.
it even tells you, predicts like the next day. So if you're like making plans, not always right, but it, kind of helps you plan your exercise or whatever it might be.
Right.
Lori,
Okay.
I wanted
Yes.
to mention there's someone on with their hand up, and they've had their hand up for a while, and I
Okay.
wanted to make sure that it wasn't something we're missing.
Okay, I'm going to, this is J.R. Paguli. You have the option of unmuting now if you still had a question.
Maybe it was a hand up by error.
Sorry, guys. I had my hand up accidentally and I didn't even realize I'd hit that one.
All good.
No worries. Thank you. Well, I don't see, let's see. One final question. I know this was not part of the studies and presented data, but just wanted to ask if VOG could have a similar effect. VOG, I'm wondering if that's fog or VOG, is VOG a term? Could have a similar effect, if at all, as the wildfires. Hawaii often have heavy VOG days.
Yes, I'm not familiar with VOG. I do know that, like,
So
fog or smog.
We're getting clarification here. Go ahead.
Yeah, VOG is an SO2 type of thing expelled by the volcanoes over here, and so it is a thing, settles in the lower areas and causes irritation.
Yeah, I was going to say, I know for smog it has similar concerns, probably for VOG as well. I think anytime you have, stuff that you're breathing in that your body is not happy to be breathing in, it's probably a good idea to take precautions. I don't know that there's been a lot of research specifically on fog, but I know that it's advised to protect yourself from any kind of smoke or volcanic emissions in general. So probably it's a good idea to, again, and I don't know if the same, like using N95 masks is enough. I guess, I just don't know.
The N95 mask is great for that, as you guys know, the very fine particulates from the volcano, but it doesn't help too much with the gases. And so we just advise people get indoors, don't run your 5K today, that kind of a thing.
The air purifiers, are they able to clean out the gases?
That's a great question. We've not looked into that. We just tell everybody, close it up. If you have air conditioning, put it on recycle for the day. And, as soon as we get another good wind, it'll start clearing it out.
Yeah, and it's a good idea just to remind people that, if you're spending a lot of time in the car, I know that's more of a concern maybe for California than other places, but always good to recirculate your air there too and make sure your filters in your car are also clean and replaced often.
Mm-hmm. Great. Well, we are a little past the top of the hour, so I think that's all the time that we have for today. But thank you so much, Dr. Schmidt, for sharing your expertise with us. And thank you so much, Claudia, for inviting us to present today.
Absolutely. Thank you so much. Thank you again to our speaker, Dr. Schmidt, for sharing this important and timely research, and to our partners at Mother to Baby for today's collaboration. I look forward to continuing to collaborate with you. folks on the line, MRC, members of the MRC network, Mother to Baby is a fantastic resource for you all. Please, check out their website and check out the resources that they already have printed and available for you all. Thank you again for your continued commitment to serving your communities. And you too, as well, Dr. Schmidt and Lori. Have a great rest of your day, everybody.
Thank you. You as well. Bye-bye.